All right, guys. So now we're on to pressure. Pressure is only for gaseous reaction. I think is quite obvious, right? If the reaction is not gaseous in nature, there's no gases, then pressure won't affect the equilibrium at all. All right. So when we consider gaseous equilibrium, right? Basically, we need to explain what happens when pressure increase and when pressure decrease. Okay, so it's vitally important for us to note what are the number of moles of gases on each side of the equilibrium. Okay, so in this equilibrium, we have more reactants and less products. So it means that when pressure increases, equilibrium is going to shift to the right, all right, so that we can form fewer gases molecule. All right, so this is the consequence of shifting right. More of the product, less of the reactants. Once again, Kc is not going to change because it's only affected by temperature. Okay, so you're going to see the opposite happening when the pressure decreases for the above reaction. All right. Okay, so the graphical representation, you can see all three of them, right? Their concentration actually spiked up at T1. All right, so this means that the pressure increased for all of them. Okay, so it also means overall volume probably is decreased. All right. Okay, what happens if an inert gas was actually added to the above equilibrium mixture? Okay, so if an inert gas was added, it means that the volume was kept constant, right? So overall pressure will actually increase, but there is no change in the position of equilibrium, okay, as the volume of container remains the same. And the individual partial pressure also stays the same, all right? So there will be no change if you pump in an inert gas. Okay, quick check. Okay, what will happen to the equilibrium composition, right, if the pressure of the above system is decreased? So if you look at the equilibrium, you have 2 moles of gas for reactants and 2 moles of gas for the product. So no matter how you're going to shift the equilibrium, right, the number of molecules of gas is going to stay the same. All right, so the equilibrium is not going to shift. Pressure change will have no effect on this equilibrium. Okay, now let's look at catalyst. All right, catalyst increases the rate of both forward and backward to the same extent so that equilibrium is reached faster. Okay, this is from your kinetics. Okay, so graphically it will look like this. It's just faster, but the concentration once it reaches equilibrium is the same. All right, catalysts have no effect on all these things. All right, no effect. It just helps us to reach equilibrium faster.